All right, welcome back. Let's talk about Java a little bit more. So we learned a little bit last time, hello world, and some of their types, very similar to C++'s types. Let's do object-oriented programming, because that's what Java is all about. So let's make a class. Let's do a counter class that we know and love from C++. Let's see how it works in Java. So there's still the idea of a constructor. Let's make a counter class with like a getter and like an increment method, and then like reset to reset our count back to 0. So let's see. I want to be able to like make a counter and do the following, right? What should the constructor do? There should be a count member variable for sure. We'll make it private. And the constructor should start it at 0. And then if I say c.inc, that same kind of syntax is going to work in Java. That's how they do their object-oriented programming stuff. So I can like inc it a few times, 1, 2, 3, however many I want, 1, 2, 3, inc it a few times, and then reset should just like 0 it back out, let's say. Let's have a reset method like that like zeroes it back out so you can redo everything, clear the screen. Get count should just return the count inside the counter. And for fun, let's also make a reset method that takes something. Let's do something like this. Like we want to be able to do this as well. c.reset to like 42. Like let it have a parameter as well. Like, okay, now the count is 42. All right, that's what I'd like. So let's get started with just that much. Okay, and I'll show you what needs to happen here. So let's make a new file called counter.java, because if my class is called counter with a capital C, it better live in this kind of file, right? So public class counter, and you can have a main function inside this. It's not part of the actual class, or sorry, it is part of the class itself. It's not part of any object of the class. So you can still have a main function, public static void main string bracket bracket args. And this is just like it exists in addition to the counter class, and I can make counter objects like counter C, stuff like that. But it's not going to look exactly like that. Okay, so that's the start of it all. Let's see, what do I want to do? Yeah, let me pretend I have everything. How about that? Here's how you would use the counter class if you made one. You have to use new, first of all, to make all of your objects in Java. So that's going to be a little different looking. You have to say new counter. All right, so counter, you say counter C. You can't just say semicolon. There is no concept of making objects on the stack in Java. You have to say new counter. All right, and we'll call the default constructor. We just have to say it like that to call it without anything. All right, so that's what it's going to look like. It has to be made on the heap in Java. All right. And then now we can let's pretend we have all these methods, and let's try to use them. So what should happen if I print out the count right now? Println c.getCount. That should print out 0. That's what the count should be right now, yeah? And then, all right, I want to be able to increment my counter, c.inc. That's how that syntax is going to work. Inc it a few times, make it 3, just like my drawing here. And then now the count should be 3. That's what we should see printed. And then c.reset, just doing it in this order. Reset without anything should reset it back to 0. So we should see 0 again. And then if we increment it some more, now it should be what, 2? Because it was 0, 0, now 1, now 2. Okay? And then we also want a reset that takes stuff. So like a reset that takes a value to change everything to immediately. Set the number to that inside the counter. And then if you inc it a little bit more, now we can make it like 45 or something. Does that make sense, what we want there? So like that's how I want to use my counter. And now I need to give all of these implementations. So this is the counter class, by the way. So I'm going to make it within these curly braces. This main is like different. It's outside. It's not part of the real class. It's not part of any object. It's just part of the class itself. All right. So go read about static methods. Those exist in C++ too. And yeah, let's get right on into it. Let's have constructors and get count and inc and reset and all those fun things. So the first thing I want to say is public and private, they have to go everywhere. So like public class counter, public main. If I want a member variable, I'm going to say private int count. That is my member variable inside the counter class. I'm already inside the counter class. I hope that makes sense. All right, so that's my one field. We'll need one field called count. That's what we want to call it. And it's private. Count is private. And I have to say that everywhere, okay? And then also, when I'm making methods, there's no concept of declaration in Java either. You just say it and like it'll find it in any order. There is no such thing as function/method declarations in Java. You also can't like have a section that's all marked as public or private. You also can't say like public colon or private colon. That doesn't work. You have to say it next to everything, all right? So yeah, the moral of that story is, so you have to put public or private or whatever next to everything. Okay, and so yeah, let's do the constructor now. We just give it in any order, doesn't matter. Java will find it even if we do it after the main function, does not matter. All right, so let's do the constructor. It's not static. This is going to be an actual method on the counter class. Every object gets it, so it's not static. Everything I'm about to write is not going to be static anymore. It is part of every object. So public counter, that's what a constructor is, right? It's called counter, has no return type, just like in C++, and it's public. And then what do I want to do? There's no concept of initializer list, so you just say, like, I want to set the count to 0, and that's my member variable. You do it like that in Java, okay? So there's that. Get count, oops. What is that one? It's still public. It returns an int, and it's called get count. And it just returns whatever our counter's count is, and get count should be in C++, a const method. That isn't really a thing in Java. There's a way, there's something called annotations that you could add to kind of help along with that idea, but there's no real concept of it. So we can't mark a method as const, let me say, very easily in Java. It is kind of possible, but it's not something that you learn right away. So there's that, and then what about inc? So it's public void inc method, right? What should that do? Count plus plus. And yeah, now we need the reset. We need a reset that takes nothing and a reset that takes something. And in Java, those have to be separate. In C++, you could have done this. You could have said public void reset, like give it like a new count, and set it equal to 0 if you don't give anything. And just say like count equals new count. This equals 0 thing, these default parameters, those don't exist in Java. So you have to have one with something and one without, all right? So you need a separate one. So you need 2 resets, one with nothing, like set it to 0, and one with a parameter, okay? So Java does not have default parameters, so you have to make 2 separate reset methods. All right, I hope that makes sense. And yeah, if we zoom out, that's pretty much it. All of these things, these are non-static things, so they belong to every object. So every object gets a count, gets a constructor, get count, inc, and 2 kinds of resets. And then here I am in main, my static method, which is just like a function as far as Java is concerned, and every other language that has them. I am making a counter object and messing with it. All right, so let's see if we get what we wanted. Let's do our best. So to compile, it's javac, counter.java. That creates a file called counter.class, and we can run it with Java counter. It goes and finds the main function inside there. So I got my 0, 3, 2, and 45. Beautiful. All right, so that's working. Yell at me if you have any questions about that. I think the last thing I want to say is operators. So sadly, you cannot overload operators in Java. It's very unfortunate. Like, we love the ability in C++ to be able to do like C plus C2 on counters. Like, we can give meaning to that. In Java, sadly, that does not work, and you have to make just things with words instead, methods with words, like call it .add on C2. That's as good as you get. So that's unfortunate, but a fact of life in Java. So let's do a plus operator on our counters, and it should just add the counters counts, just like we were doing before. So in C++, so counter C2 equals new counter, got to be on the heap, and you never have to say delete. It'll garbage collect it for you. Let's put something in C2, like let's have it hold 3, and now here's how I want to use my my plus operation, my add operation. I want to be able to say like C, add yourself to C2. Sadly, we can't use the plus, but that's as good enough, I guess, in Java. And then the counter's count should be, this was holding 3, this was holding 45, so this should hold 48, all right, for C3. So let's confirm that. So this is C3.getCount, oops, C3.getCount, and that should hold 48 in theory once we get this add method ready. So okay, let's do an add method. It's going to be called like this, like it's on us, like c.add c2. So you got one counter that is yourself. You have your own count, and then you have some other counter. Okay, so it's going to be public. It's going to return a counter back, a third counter. You're adding them up into a third, and you're going to add yourself into another counter called other. So there is no concept of reference variables. Like you're passing along these things. They were made on the heap. You're essentially passing along their addresses. But when you make something new in Java, you don't get back a pointer. You get back what Java calls a reference, which has nothing to do with a reference in C++. Unfortunately, it's just their word for kind of like a pointer that you don't have to use an arrow on or dereference ever. It'll do it for you. And so you just you're able to start using the dot like I was doing here. So this is called a reference that it gives you back on the heap. All right, it's nothing similar to C++ references though. And so yeah, you're just passing along the other counter, and it's essentially passing it by a pointer. And so you don't have to worry about copying or anything like that. You're getting it passed in an efficient way. But if only we could have const parameters, that would be nice here, right? Because we're not really touching other, we're just using its value. So, okay, we would like to make a third counter with a count inside of it that is the sum of my own count plus this other's count, okay? So, okay, what's the count that should go inside? Its sum count is my own count plus the other's count. So that I'm inside of the counter class. I can do the dot and get private stuff, that's fine. And then let's make a counter that I'm going to return. So counter result is a new counter, and then I want to fill it, right? res.reset. Have a nice method that does that to that sum, and then that's what I return. Return res, and that's why the return type is counter. Okay, so that should do it. Java C, Java, and I do get my 48 when I go and I call it with those two particular counters, with a count of 45 and a count of 3. Okay, so yeah, that's nice. It's working, and I hope that makes sense. Okay. Yeah, and so also main is void. There is no return 0 or anything in Java. Let's see, what else? So here's just like a big long list that I stole from Bill Kearney that tells you the differences between Java and C++. Some of these we've talked about already. So like we were saying over here, you need to install Java in order to run a compiled Java program. It's not ready to run on your CPU just yet. So it's compiled to what's called an intermediate language. It's Java bytecode. It's not actually machine code yet. But their slogan is you compile once and you can run anywhere that Java is installed. So that's a nice thing. Instead of const for constant variables, at least, you can say public static final. Make it part of the class. And then final means like it can't be changed, like a variable's value cannot be changed. So that's their version of const, at least for constant variables. Instead of char, they say byte. And yeah, there was no such thing as pointers, only references, which kind of function like pointers, where you can just immediately use the dot. It's going to do it for you. There is no operator overloading like we saw. So sad. We had to make our dot add instead of a plus. But that's just a fact of life in Java. Unfortunate. We have to import packages rather than include libraries, all right? Rather than namespaces and like number sign include. So their libraries are called packages, and we import them in Java. I'll show you an example of that in just a second. And then there is also a concept of inheritance in every object-oriented language, Java included. There's something, this is something you should maybe read about in your book if you can. It's going to be useful knowledge before you get to CSCI 41. But remember how I was saying, when we had IF streams back in C++, that inherited from the type called iStream, and that was where like your IF streams got their operator like read in from the file, just like cin. So that's where that lives, and that's why like cin has the same thing, because cin was an iStream, and IF stream inherits the properties of iStreams. So that's a thing you can do, inheritance in object-oriented programming. So classes can inherit from stuff, and by default, when you make a class in Java, it inherits from a default class called object. So everybody, the counter class, we didn't say otherwise, it's just like by default going to inherit from a class called object. And like everybody, that's like the root class, and you inherit some features of object. And so I wonder if I can show that to you very quickly. Can I search for the word object? Let's see. I think, yeah, it is in order, so we'll get there eventually. LMN, yay, there's object. So here's the class object that everybody inherits from. And like here's all the methods that those get. There's like a clone method, there's a toString method that you probably want to override, but like every class that you make has a toString that you can call on it. Essentially, that's what that means. All right, so that's cool. That's something you'll want to read about to fully understand. That's more of a CSCI 41 topic. Yeah, the compiler is pretty nice to you, and documentation, if you just write some cool comments in a fancy way in Java, it will turn into like HTML documentations. Like all of this entire page that like you can click on other stuff and look at the documentation, this is all extracted from the source code for the Java standard libraries. Isn't that cool? Like it made this website out of their comments, which is really nice. So that's like next level. That's really cool. Yeah, automatic documentation system. And yeah, we know about the garbage collector now. We said new all over the place. Down here, we said a lot of news, and we never needed to say delete. Java just like notices when we're done with stuff, it calls delete for us. And yeah, the standard library is amazing. And I'm going to show you an example of that. Okay, so yeah, let me teach you how to make graphical user interfaces. There is a library just baked into Java inside of their standard library to make graphical user interfaces, or GUIs for short. All right, so we're finally going to be able to make windows and things that we can click. All right, so the library, the package that we're going to use in Java is called Swing. JavaX.swing. So we're going to import that package and make pretty stuff with it. All right, so let me start talking a little bit about that. So here's the finished thing. Here's what we're about to make. So I made it, it's called countergui.java. Already I've made that file. What we're going to do is we are going to make a GUI that wraps around our counter class. All right, GUI stands for graphical user interface, and yeah, our goal is to make a window that wraps around the idea of a counter. So like we can press like an ink button, a reset button, and it will show us the count. That's like what I want to do. So yeah, there's a bunch of different pieces. They call them components in the Swing library. That's what we're using in the Java standard library to get access to make windows and stuff. All right, so here is the Swing documentation. You can like read some stuff, but all their things that we're about to use start with J. It's like J something, like a J button we'll put in our window. A J frame is the window itself. And then like to show the current contents of the counter's count, we need to display text, and there's a J text field for that. So you can click on all these guys and like see what they do, but they all start with J, okay? And so like we want to like call the constructor to set a J text field with a certain number of columns, and like we can fill it in with text. We can set its font. We can change like what's in there. Okay, so that's where we're going. And so there's a bunch of different setting methods that we'll be using. And let's see, what else do I want to say here? So like you can scroll down and look at all this stuff. So we'll be using those. But in general, let's see what we're gonna do. So what we will do is we will make a counter deep down, and that will serve as like the database for our window. All right. So like here's the window I want. Maybe I should draw that first. Like I want to make this. I want a window that shows my counter's count, 0, and then I want an ink button that I can click and a reset button that I can click. And every time I click it, it should increment the counter and like show a 1 there. So there's going to be a little database. We're going to store a counter object that has a count inside of it, like starts at 0. And when we click ink, it will call ink on this underlying representation in memory. This is like our database. And then it will refresh the screen to show the new count. Does that make sense? Like you press reset now, it'll change it. It'll call reset on the counter, and then like always refresh the screen to show the current count of the counter in the field. Okay, so that's where we're going. So yeah, to arrange a bunch of things. So this is, first of all, these pieces. This place that shows text is called a JText field. There's also a JText area that you can look into. There's other things. Let's start writing all these types. So this is going to be a JText field. We're going to need that. It's just you make an object and it turns into something in a window. JText field. And then these two bad boys are called JButtons. So that's this one. You have a J button that you can put some text inside of, and you can tell it like what it means to, like what code do you want to run when it gets clicked. Because that's pretty much what needs to happen, right? J button. And then as far as windows go, to make a window, it's called a frame. So you make a J frame, and that's like a window that lets you put stuff in it. So there needs to be a frame that like contains everything. And if you want to have a bunch of these components all in a row like this, you have to use a J panel to arrange them. So this is just, you have to learn the library, learn all their words, but this is going to be the J panel that's going to display things from left to right. Okay, so yeah, I'm going to make a text field, a J text field, 2 J buttons, shove them into a panel, and shove that panel into a frame. Okay, that's what I'm doing, a J panel and a J frame. That is my goal. And so here I've already made the code. Let's just walk through it. So it's this one, counterGUI.java. It's going to import these packages. So javax.swing, the star means everything. So import everything out of javax.swing. And that's Java's include. And then also for clicking stuff, like buttons need to run code when they get clicked. Those are called events in Java. So we have to import stuff that deals with events as well. All right, so I've made a counterGUI class. And then, yeah, what I want to do is in the main function, make a window and all this stuff and display it. All right, and we're going to have on the back end a little counter that's going to serve as our database. All right, so here's a counter object that we're going to save stuff for. All right, so we're going to use a counter under the hood to keep track of our data. It's like our database. And we don't have to import counter like we were doing up here. It's just like it's in the same file. It's in the same folder as us right now. So like Java just finds it. So that's nice. And then here is a static field. A static field is like a global variable in Java. All right, it belongs to the class. There's only one, counter C. It's because it's static. All right, and it'll be private. Why not? So all right, now in main, we're going to initialize our little global variable C to a brand new counter, and it's like its count will start at 0. That's our database, and we always want to show its contents on our screen. All right, so that's what we want. And so yeah, we're going to make a J-frame and a panel and some text fields and J-buttons and all this fun stuff. But just to motivate you to understand all this, let's compile it and run it. So Java C on the counter GUI. And then I want to run the main function in counter GUI, not in just the counter. So I say Java and counter GUI now. So I made a bunch of files. So it's this one I want to run. Counter GUI. Hit enter. And then here it is. Here's what we're making. See it? So it's got the little text field. It's got the increment button, and I click it. I'm going to call inc on our counter and increment its count. And then the reset button will set it back to 0 so you can try again. Isn't that cool? So yeah, that's where we're going. That's what we're building. So here's how you build it. So we got our database, and now we want to make the window itself. That's a J-frame. All right. And so you can read the documentation about all this. Like what does a J-frame's constructor take? One of them takes the string that you want to display on the window. So that's the constructor we're going to call. So it takes the title of the window. And so maybe you didn't see that. See the title? It's counter GUI right there. That's what we're putting. That's how you use the library. Different libraries work differently, but that's the secret there. And then for some weird reason, your windows in Java, they don't like the X button doesn't automatically close them. And so like we change that. Set the default close operation to be exit, please, frame. So that's what we do there. And then we want to arrange all our stuff in a panel from left to right. The panel does that. So it's a J panel, default constructor. And then we get ready, right? We're going to make a text field. And the constructor for the text field takes how wide you want the text field to be. So we're going to make it 3 characters wide, so it can go up to like 999 and be visible still. So the J text field lets us put text in it. And we want to change the text of the text field manually in code. So we don't want to let the user type in the text field. So we're going to set editable to be false. And then the text in the text field is a .setText method that sets the text to the text field. We want it to be always matching whatever our counter's count is. So like go, get our counter's count, convert it to a string because the set text needs to be a string, and then give it that. And then like initially it's going to set it to 0. So that's why that line makes it set to 0 the first time. And then I found a helper little function on the internet that changes this font size of any component to a certain size. So I made the font huge for us. So that's this. I stole that from the internet. You don't have to worry about it. So I'm running that. And then, yeah, now I'm doing the rest. So I made now we make the J buttons, the buttons and the reset, increment and reset. So for J button, it also has a constructor. They all do. And the constructor of J buttons, at least the one I want to use, takes a string that has like the text in the button. So it's called increment. So I want to put increment in the J button, make the font size of it huge, and then you have to give what code do you want to run when the button gets clicked, because that's the whole point of a button, right? You click it and it does something. So what do you want done? Here's how you do it. You put a little, like I'm making an action, is what it's called. It's an action listener, listening for the click event. It's like, I guess the code kind of shouts out whenever you click it. It can hear your mouse. That's the metaphor, I guess. So it's called an action listener. and we have to override this action performed method of an action listener. So I'm like making a function on the fly here, which is a little complicated, but don't worry about it. These 2 lines are what I want you to pay attention to. So, all right, inc button, whenever you get clicked, run these 2 lines of code, which increments our database, our counter, right? Change it to be bigger, and then always refresh the screen to hold the current counter's count on our text field. Right? That's what I want. So those are the 2 lines. Increment the counter, and then make sure to like refresh the screen to be whatever the current counter's count is. So those are the 2 lines. Do you see them? And then same for the reset button. Call it reset, make the font huge, and here are the 2 lines I want to run whenever the reset button gets clicked. I want to reset the counter, and then make sure that the display window has like refreshed itself, like change the text to that to like correspond to whatever the current counter's count is, because I just changed it on that line. Does that make sense? So yeah, their string conversion method is in the integer class. Integer.toString takes an int, converts to a string, and that's pretty much it. Those are the things. I made all of my pieces. I need to then put them in a panel, so I add them to the panel. So I'm saying panel, add those 2 things in this order, right? Text field, then inc, then reset. It'll make them from left to right. And then I add the panel to the frame. I say frame dot, like some stuff, add panel. And then this dot pack, what that means is by default, the sizes of the windows in Java is like as small as humanly possible. I don't think I can show it to you here. Can I do that? Like by default in Java, it makes the window size nothing. And dot pack, what it does is it like says, hey, I've put some stuff in you, frame, just resize yourself to be perfectly as big as those things. It resizes the windows to fit the contents. And yeah, that's what you do. And so we've been building the window this whole time and setting things up. By default, the frame is invisible. We haven't shown it to the user yet. So at the very last piece of the puzzle is to say, frame, we're ready to show this to the user. We've made the window, it's ready now. So set visible to be true, and then now it works. It calls all those things. And yeah, this is a fun little example, I think. So that's how powerful the Java standard library is. They have this like window GUI graphical user interface features just for you to use. Cool. All right. And so yeah, that's what I wanted to show you in Java. Let's switch gears to Python now, because you might be required to learn that. Right? You might be forced to know it in a future class, all right, or if you transfer. So here's another website, Learn X in Y minutes, same website, but another page on it. And there's one for Python. So you just scroll down and you learn Python in just one big file. And at the very bottom, they have like next steps if you want to do more things, learn more stuff about Python. So I highly encourage you to read this stuff, because Python is a very, very popular language that you should definitely know before you leave here, all right? Because pretty much every UC, for example, if you transfer to a UC, they're going to teach Python first, and they're going to I expect you to know it by the time you get there, okay? So keep that in mind. And yeah, it's called Python. Their mascot is a snake, but it isn't actually named after a snake. It is named after the Monty Python comedy group, if you've heard of them. So you will see, if you look at their documentation pages, they have a bunch of puns related to that, and that's why they've called some things certain names based on the Monty Python group. So that's pretty funny. And you will enjoy it if you know about that. But yeah, let's do Hello World in Python, and you will see why a lot of schools teach Python first, because it's just going to be a one-liner. It's just going to be a file with one line of code, all right? So yeah, in Python, your file extension is .py, and to make code run, there is no main function. You don't need one in Python. You just start writing lines of code, and so all I need to do is call a print function. So it's called print in Python. And then you put what you want to get printed, so like hello world, hello, ... There's no semicolons in Python. You just put it on a line like that, and it's done. That's what you run. All right, you just start writing that code. So here, let me show that to you. So here's your hello world in Python, hello.py, we'll call it. And then it's really just this, print hello world. There you go. And it'll print it with a new line at the end by default. So to run it, there is no concept of compilation in Python. You just say Python, it's a version 3 of the language, so you say Python 3, and then the name of the file that you want to run, it just runs the file, runs the contents of the file. All right, so Python 3, hello.py, hit enter, there you go. You just ran all the lines in the file, that one line, okay? So let's see. Comments in Python. Do I want to get there? Yeah, comments in Python start with a number sign. So those are single line comments. It's just like for makefiles, right? So this, in Python, this is a single line comment. If you want multi-line comments, you do like 3 either single quotes or double quotes, and like you match them. So like this is just like a really long multi-line string essentially, and that considers it to be a comment. So this is a multi-line comment for Python, and so like nothing has changed. I rerun it, it's just the one real line of code that gets run still. Okay, so that's that. Let's see here. Let's talk about the main differences between Python and C++ now. So the big thing is there's no compilation. There's no like Python compiler by default. So what happens is Python is just like you say Python run this file, it looks at the contents of the text of that file, character by character all over again. And it's like, all right, print, that means print. Let me figure out what to print right now. And then it goes and does it. All right, so it's kind of inefficient. All right, we call it an interpreted language. It's reading the contents of the characters of this file every time it wants to run it. All right, and so there's no compilation. And so if you have comments, it has to like read until the end of that line. Like that doesn't just get compiled away. So comment. So like you can do this, like print 2 + 2. This is your file, for example. Print hi. Every time you run this in Python, it has to reread all the characters of this file. Like it has to read all the number signs. Like, all right, that's a comment. I'll read till the end of the line. And that's wasting time. You see that? So, and then it's like, all right, print, what do I need to print? 2 + 2. All right, let's convert those to ints and like do the stuff, and then I'll print that. And then print again, quotes hi. Okay, it wants me to print hi in a new line. I'll do that. That's slow. All right, Python is significantly slower, at least 10 times slower compared to C++ and Java because of this. All right, because there's no compilation process, it has to read the characters of your file every time it runs. All right, so there's that. Let's see, and then types exist. Like there's still a concept of an int and a string, and they're different, but you don't have to say them anywhere. It's called dynamic typing in Python. It'll just kind of figure out what type you wanted and put that into your variable. All right, which is kind of interesting. And because of that, if you ever mess up with the types, like you try to add weird things to the wrong stuff, then you're not going to get a compiler error because there is no compilation. You're only ever going to get a runtime error. All right. So a lot of things that were compiler errors in other languages like Java and C++ become runtime errors in Python. Okay, that's a little weird because there's no types that you say. Really, you just say def for functions. There's no return type that you say somewhere by default, at least. So here, let's make a new file, more python.py, and so. Yeah, there are no types. There are no types that need to be declared, at least, in Python. It'll just figure that out. It'll figure out what types you needed in Python. So it just figures them out. So you can say, all right, x equals 42. That's how you make a variable in Python. There's no semicolons. It's just it's line based. So like that's the whole thing on that line. That's how it knows when you're done. So you can't have like multiple lines, y equals 42 or something. There is no semicolon in Python. You got to separate by lines, which makes your code look cleaner, honestly. So you can say print x. And so this is more python.py. And so there's my 42. It's going to print it. It does know, Python does know the types of things. It's just like you don't have to say them up front. Like it'll figure out like, okay, yeah, x was supposed to be an integer, and Python calls that int, just like every other language we've seen. You can ask it like, what's the type that x holds right now? It can know. It knows. It keeps track of it. It's like, oh yeah, x was an int right now. All right. And now I'm going to do something that is going to disgust you. All right. This is the key for dynamic typing. This should make you feel very uneasy. All right. And that's a good thing, honestly. I've taught you well if you feel uneasy after this line. X equals a string. Python will accept that. It is going to be fine with that, and it will print it. It will print it. Oh yeah, you want x to be a string now? Sure, there you go. And it knows the type has changed too. Isn't that disgusting? Oh yeah, they call their string str in Python. That is horrible. I hope you agree with me. That's just the source of so many errors because you can change the types on the fly. It's dynamically typed, and I hate it. All right, and I hope you hate it too. If you do, I've taught you well. All right. So some people enjoy it, but I think it makes for, like, when you have large files in Python, you can mess up with the types very, very easily, and it's very hard to track down. Okay, so yeah. Because also the types are kind of just inferred for you, there's no return types when you're making your functions. To make a function, you just say def, all right? You say def to define a function, and because there's no semicolons or anything, there's also no curly braces. It's just a bunch of white space that defines the contents of things. Like if you want the body of your function, you tab over, which is cool, or you just like put spaces. So it's like white space. Indentation is very, very important in Python. There are no braces. It's what's indented becomes the body. All right. I hope that you enjoy that. It's super cool. And I just knocked around my my microphone. Okay, it's still working good. All right. So yeah, there's no braces, just white space. So here, let's make a simple function that adds 1 to something. So it's like, here's how I want to use it. Like print add 1 to 42. It'll print 43. This will compute 43. All right, return 43. So here's how you make that add 1 function. You say def add 1. There's no return type, and then like I want to call my parameter y. Again, there's no type declaration. Just say like, all right, the first thing's called y, whatever its type is, and then you tab over. You give a colon, and then you tab over, and like everything that's indented becomes the body. That's how it knows. So it forces you to write clean code, which I like. I wish this were a thing in C++ or Java. Everything that's indented is the body of the function. And so what do I want this function to do? Just return y plus 1. So that all works the same, just no semicolons, because it's all line based and white space based in Python. So there's my 43. It is working. It's happy. What else? Instead of arrays, Python calls it a list, but it functions like an array or a vector. So here's that. So this is L equals, and they do square brackets. 1, 2, 3. So here's a list. So the following is a list, and like you can print it out, print the entire list if you want, or you can print a piece of it with array-like syntax and be like print L of 1. Index 1, indices start at 0 as usual, so that'll print the 2 out. And then here's something disgusting along the lines of this again. This should also make you feel very uneasy. 1, 2, hi. Python is cool with that. It's fine. It's happy. L of 2, yeah, that's a string. Sure, that's fine. That's disgusting, I know. And then also, for strings in Python, there's no like concept of a single character. And so strings, which they call strings in Python, can use double quotes or single quotes. It doesn't matter, because it doesn't have like single quote characters in Python. So it's like I could use single quotes to have my strings in Python, and it won't care. You don't have to press shift as much, I guess, which is nice. So there's my hi. Cool. Disgusting, I know. And yeah, instead of else if, combine else if separate. When you're doing like if else's on your statements like that, they combine them to just say elif. Okay. So let me show that too. Let's do like a grade calculation program. So like if the grade is 77, how do you calculate if it's A, B, or C or something? Let's just do A, C, or F, hard code it. So like if the grade is greater than or equal to 90, or 90.0, then print A. I'll use single quote strings. And in Python, you do not need any parentheses here. It just knows like the condition is everything up until the colon. All right. And then instead of saying else if grade is greater than or equal to 70, like it's a C, it's going to be elif. That's what they do in Python. So they just like get rid of these guys. They call it elif. Else if is not a thing. Elif greater than or equal to 70, print a C, and then else it's an F. Okay, and so that's how their if else's, it's if elif else's now work in Python. So there's that. What next? Let's do a counter class again. So methods in Python, they have to you have to forcibly declare your secret this parameter when you're defining it. All right, so we need to talk about that. They call it self in Python. And so you remember how in C++, like secretly what's going on under the hood when you say like you have your counter class, you say c.inc, it's really being translated into this, right? Counter colon, this is C++ again, right? Inc. And then even though there wasn't a parameter here, this is secretly like a default -1 parameter, 0th parameter. It's called this in C++. So it's really being passed along the address of that thing, and that's how it knows which counter to increment. and there we go, third time's the charm. That's what it really is running. Okay, so that's what happens, and we have to be very explicit about that when we're making methods in Python. We have to take that thing, even though when we use it, it's taking nothing. It's getting the object. We have to secretly declare that explicitly in Python, and they like to call it self. All right, and then also Python's libraries are really cool. I'll show you that in a second after we do this one. Let's do a counter class. Again, indentation is very important. It's going to be class counter : tab over, and yeah, every method call is going to automatically pass along the object as the first argument, as the secret 0th argument, but every time you implement that method, you have to explicitly take that first argument, and it's called self. All right, so things that usually take nothing now take something. You spell this fact out in Python, and I know that doesn't make any sense without an example, so here's an example. All right, code is worth 1,000 words, so here, let's call it counter.py, and so here's how I want to use my counter class first of all. So I'll say like c equals counter. You don't have to say new or anything in Python, just say call the constructor like that, and then c.inc will still work, like c.inc, 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 print c.getCount. That still works, it's happy. And this should print, what, 3, right? What I'm saying is this line in Python, just like in C++, this will get translated by the Python interpreter this time. Gets translated into, it's essentially a call to the inc method on C. And we're going to explicitly take that thing, and we're going to call it self. All right, that's what I mean. So, all right, we're going to make the counter class counter, and then everything that's indented is part of the class. The constructor, we don't call it counter in Python, we call it __init___, which is disgusting. But that's how they do it, so we say that. So constructors in Python are called __init__, and then also every method, like I was saying, every method takes an explicit now. Even though when you call it, it's going to be implicit, it's going to take it explicitly, explicit self parameter. That is your object first. All right, and we're going to mess with that. But it, like I said, it's automatically, but it's automatically passed when you call a method. Okay, that's what I mean by that. And so yeah, let's make the init. Say def init. That's your constructor, and it's going to take self. All right, that's what it's going to do, self, and that's going to, like, you're getting yourself when you're calling it, even though when you call it, it's not really there, but it's being passed. All right, and that's how you make your parameters. Or sorry, not your parameters. That's how you make your fields and your member variables. So to make your count field, it goes in the constructor. You create it in the constructor itself. So let's make a field called count. So that's what every counter object should have, right? And so like every field, it gets made in the constructor. All fields get made in the constructor, which is crazy because you don't have to declare anything. And so that means, like, in an if-else, you could make like some fields if you go down one path of the if-else and some other fields if you go down a different path, which is disgusting, but possible in Python. So you're going to make it through yourself. So you're going to say self.count. That's where you make your field equals whatever, like, let's start off at 0, all right? So yeah, this right here, the count member variable gets made right here the first time you ask for it. All right, so you have to go through yourself to get access to your member variables. All right, that's what I mean by that. And so now, like inc, your method called inc, def inc, it takes explicitly yourself, the object that it's being called on, even though when you call it, you don't say it. All right, that's what I meant by that. Like, how do you increment your own count? You got to go through yourself. My own count, incremented by 1, equals self.count plus 1. There is no plus plus in Python, sadly. Can't do this. That doesn't work. Plus equals still exists, though, so that's the shortest you can make it. So that works. And then get count, right? Get count similarly explicitly takes yourself and it returns my count, self.count. Does that make sense? Even though when you call it, it doesn't take anything. It's really, this is being passed into here, and it's called self. You got to take it explicitly, though when you call it, it's implicit. I hope that makes sense. All right, it's a little weird, but that's the secret. There's your class, there's your counter class, and then here I am using it down there. Let's take a look. So there's my 3, all right? You can have default arguments in Python, that's nice. Let me draw a picture before I talk about that. So here's kind of what self meant, all right? So you always, when you call a method, you have, like, here's the object you're calling your method on. I'll call it current obj. All right, and so here's my object I'm calling my method on with all of its member variables and whatever. In C++, whenever you call a method, you're getting in the this a pointer to yourself. So like this in C++, inside of any method call, is a pointer to your current object. In Python, they're calling it self, and it's kind of like, it's like a reference, essentially. It's a way of getting at this object and going inside of it. That's what's going on, all right? So there are also, that's what I meant by all this. There's also default parameters in Python, so you can say, you have a default parameter called, let's say, like, in the constructor, you can pass along the count as a parameter called count, like, what's the initial count you want this to be, and you can default it to, like, it's 0 if you don't pass anything. So, like, set the count to the count parameter. And so now when I'm saying down here in main, just like this, it's calling it with like yourself and like is going to be passed along as 0 for the initial count. So that's still going to all work out. But now we can make an explicit call to our constructor and ask for a count. So I can say this now. I can say C2 equals counter, and I'm going to call it with something. So like 42, all right? And then I can say C2.inc a few times and print C2's get count, which should hold, what, 44? Now you can do that. So now I've added this. And so like this, it looks like it's the first argument, but really yourself is being passed in the constructor first, and then the count. So this is really the second argument. It's going into count, all right? And so we gave something that wasn't the default, and so it's going to set the count to whatever that was, 42, all right? And that's also how there's no ambiguity here. Like this is your member variable for sure because you're going through self, and like this is not your member variable, it's this. It's your parameter, right? You can't get your member variable without going through yourself, okay? So that's interesting, and I hope that makes sense. All right, so that's Python classes in a nutshell. Yeah, the last kind of thing I want to show you is, here's a fun library. It's called the Turtle Library. It's really cute, and so here's the documentation page about it. It lets you draw pictures. It's very fun. So it's the Turtle Library, and we import it. Just like in Java, you say import the library. So you say import turtle, just on the first line, and then that gives you access to turtle stuff. And here's the silly, the metaphor. This is a useful thing. I use this in my CSCI 1 class to teach students programming. I do teach Python there. So here's the metaphor. There's a turtle, and somehow his tail has been dipped in ink. All right, so here's my best drawing of a turtle. His tail has been dipped in ink somehow, and this is a sentient turtle. You can command the turtle to like go and like walk forward with your tail down. It'll make a mark. Turn left, turtle, by 90 degrees. And make more marks. Go forward some more. He can like move that way. Like you can tell him to turn left and like pick your tail up and down, move just a little bit, and you can draw a dotted line. So like that's what you can do. All right, you can ask this little virtual turtle to move around on your screen and draw stuff. Tell him to go forward, turn left by a certain degree amount. That's what we're gonna do. Okay, and so you can read up on all these different things that you can do to your turtle. It's very fun. But yeah, the first thing you do is you say import turtle, and then that gives you access to all these functions in the library, but you have to qualify them. All right. You have to say, like, if you want to go forward for the turtle, any function in the library, you have to say like this. It's always the name of the library, turtle, that you just imported, dot the name of the function, and then you call it like that. So it's always like, if you want to call the forward function on the turtle library, you're going to say turtle.forward by a certain amount. Okay? Does that make sense? That's what you do. And so yeah, it's for drawing stuff programmatically. It's really cute. And there's a concept of a coordinate system. At the beginning of time, the turtle will start out in the coordinates 0, 0 on the screen facing east or to the right. All right, so that's what the turtle will look like. Let me show that to you. All right, it's gonna be cute. So I'll call this turtle example. And so I want to import the turtle library, and you can have the by default, the turtle looks like a little arrow, which is dumb. I think the turtle should look like a turtle, so you can change his shape. You can say, hey, turtle.shape, where is that? Turtle.shape, and as a string, you can give turtle. You can tell him to look like a turtle. So, turtle.shape, turtle, in quotes, which is cute. Much better that way. Python 3 turtle example. And, oh, sorry, also to just keep the turtle, like your beautiful picture up on the screen rather than immediately exiting, you have to say turtle.done at the very end. All right, that just says, hey turtle, I'm done with my beautiful drawing, just keep it on the screen for me to see now. I'll close the window when I'm done. So keep the window open, because this is a little drawing window that gets created. So there it is. So here's my little turtle. There he is. He's in the middle. 0, 0, 0 is his coordinates right now, and he's facing to the right. You see his head? Isn't that so cute? And his default color is black, but we can change that later. So here's what I want. So all right, let's ask the turtle to draw a square. So what we need to do to draw a square, right, is like we're at a spot, and we're facing this way, so we might as well take advantage of that. And we'll tell him to go forward by like 100 units. Does that make sense? But I'll put him right there. So you can say turtle.forward by 100 units in your coordinate system, Mr. Turtle. Look at him go, there he went. See, he made a little line because his tail is by default down, making marks. And so now if I want to make a square, I want to turn the guy. I want to be like, hey, Mr. Turtle, you are facing this way right now. If you went forward some more, just keep going that way. I want to turn you to the left by 90 degrees. All right, does that make sense? And then go forward some more. Go forward 100 more, just like that. So that's what you want. So turtle dot, that's turtle dot. I want him to turn to the left by 90 degrees, and then go forward some more. So here, before I go forward, do you see it? See, now he's facing up. That's perfect. That's what I wanted. And so then, now we can go forward some more. Look at him go! Isn't that so cute? And so I think you can imagine what needs to happen to complete the square. It's got to be, now by default, like he's facing up, you're gonna have to like move him to the left again 90 degrees. So you could be looping this if you knew how to loop. That would work. So go 90 degrees, go forward, and then turn left again 90 degrees. Now go forward one more time, Mr. Turtle. And then he'll end up facing downwards as well, won't he? So it's just a bunch of these, right? There you go. That should do it. So look at him draw. It's so cute. So there's your little square. All right. So there's that one. You can change the color of what's being drawn. You can change the color of what's on the tip of his tail. That is gonna be .pen color. So there's also a fill color if you want to fill in your shapes, but let's just do the pen color. So you say turtle.pen color, and then you can just give a string, like I want it to be brown, I want it to be pink. You can also give these like HTML-like colors, but I'll just say, at the start, before you draw something, you say turtle.pen color and give him whatever you want. So yeah, like I said before, the turtle starts out at 0, 0, facing east, and we took advantage of that as we drew our square. And you can change his color. It can be like turtle.pen color, and you can say pink. And remember that in Python you can have single quoted strings. That also works. Now he'll draw a little pink square, and oops, it looks like something weird happened to the window. Not sure what the issue was there. There it goes. But he drew a pink square. I guess something about this call messed it up. So here, before it starts doing anything, let me have it ask for input. Let me fix the screen. I guess making the color pink messed something up on my windows. That's okay. So yeah, I'm just gonna say ask for an empty input. So like it's waiting for my keyboard before it like does anything. I'll just press enter. So here I'll just like fiddle with the window until it fixes itself. There it goes. So now here's the turtle. He's ready to draw. Now I'll press enter. There it goes. Isn't that so cute? So that's fun. All right. So yeah, let's do some more. Let's draw something else. Let's draw a triangle. Let's draw a triangle down here. So he's already facing this way. Let's have him move some more that way, and then we'll draw a triangle down here, like a little triangle. Okay. So let's first get him into position. Let's have him move forward in your current direction, Mr. Turtle, by like a lot to get down there. Let's have him move, I don't know, 200? That might work. So 200. And am I going to have to keep playing this game of messing with the screen? I guess that's fine. But see, by default his tail is down. So he made some marks there. We didn't want those marks. So what we can do to fix it is to say, hey turtle, before you move, pick your tail up. Turtle.up. We'll pick his tail up, and then we can set it right back down when we're in position. So like this, for some weird reason, does that only sometimes, which is hilarious. Come on, little screen. We can do it together. Come on. There we go. All right, go. See how his tail is up, and now it's back down. Now it's back down. He can draw some more. So, yeah, let's have it be like a blue triangle. So, like, I'll change the color on his tail now to be blue. Pen color become blue now. And honestly, you can do that before you do anything here. And then now we're ready to draw, but if we're drawing a triangle, we are facing this way right now. We want him to be facing this way. So to go from here to here, it's going to be a left turn by 90, isn't it? Left turn by 90, and now he's facing this way. And he can go forward like 100 again to make the bottom part of the triangle. So we got to left turn him. So it's going to be turtle.left by 90, and then we can go forward by a certain amount, and that will draw the base of our triangle. That should work. It's crazy how that sometimes works, sometimes doesn't. This is a weird little bug. But there he goes. And, oh, sorry, I forgot to change pink to blue. But you get the idea. Now he's drawn the base. Make it blue for now. And then, right, so now we're here. We don't want him to go forward in his current direction anymore, so like instead of going that way, well, let's say that we want to draw an equilateral triangle. Do you remember what the angles of an equilateral triangle are? They're all the same, right? So it's 60 degrees for each of these. And so we want to tell the turtle, like, all right, don't go forward anymore that way. I want you to turn that way. So you might think it's like, all right, turn left by 60, but that won't quite work. Left by 60, and then go forward 100. This is not going to do the right thing. Let me show that to you. See how he went off that way? So that wasn't enough. That was not enough. And do you see the problem? It's not turn left by 60, because that's 60 or whatever, right? It's turn left by whatever this is. It's the, what is this? It's either the complementary angle or the supplementary angle, and I've forgotten which word is the right word. But this adds up to 180, right? It's this angle that we want to move left by, whatever that is. And how do we calculate that? It's going to be 180 minus the 60, so it's 120. Does that make sense? That's what we want to turn left by. So not by just 60, it's 180 minus 60. You can just have Python calculate it. That'll work. And, all right, come on, little window. With enough fiddling, it eventually works. Beautiful. And it's the same game. You're going to keep on turning by that same amount again. It's going to be also facing this way. This angle that you want to turn left by again is again 180 minus 60. Then you go forward by that amount. Okay. So that's kind of cute, I think. Fun little example. And I think that's everything. That should do it. There's our triangle part now. All right, one last time. Fiddle in with the window. Cool. Look at him go. And there's my triangle. Awesome. So yeah, that's that. And so this dot up. Just tell the turtle ever so nicely, hey, pick your tail up. Pick your tail up, please. And I think that's pretty much the example. So that's a fun little library. It's useful for teaching programming because you get to like see beautiful works of art appear before your eyes. And so I like to use that in my CSCI 1 class. But yeah, that's most of what I wanted to say. I do have one cool example, and then I'll show it to you after this. So there is something called the REPL in Python. If you just say Python 3 without a file, it will open up what is called the Python REPL. So here it is, just like this. And so it's got some arrows. It's like a little command line for just Python. And so this is called the REPL. It's short for the read, evaluate, print loop. And so you've seen me come here a few times just to do like quick math. What you can do in the REPL is just like type a line of Python code, and it will like read it. Once you press enter, it will read it, evaluate it to an answer, and then print the answer, and then loop back around to get more stuff. So like you can do it, you can use it very simply to do like math, like what's 8 times 7? I like that. And then it's like ready for some more stuff. And so you can say, when you're done, you can say quit, or you can type Control-D to exit. But yeah, it's super useful. In Python, the numbers are unconstrained, so like there's no limit. There's no like 32 bits for an int or anything in Python. They're as big as they need to be. So you can ask, hey Python, their power operator is 2 stars, hey Python, what's 2 to like the 100th power? And it's like, that's way bigger than a C++ int could hold, but like it'll just calculate it for you. It's happy. And like you can keep going. 105, 200, 2 to the 200th power, 2 to the thousandth power. It's like, all right, yeah, that's the answer. Isn't that fun? So yeah, you can do some quick math in Python. You can make variables like x equals 42, what's x times 2. Like, it's useful. I like to use it for that stuff. And yeah, that's pretty much it. That's what I wanted to show you in Python. Let me show you just a silly example of the extent to which you could go in Turtleland. I've made an example called joydivision.py. So there's a T-shirt and like an album cover that you may have seen before. There's it looks like this. Let me show it to you. Did it go there? So dun dun dun. This one. Have you seen this album before? It's tiny because it's on Wikipedia, of course, but like it's so blurry. I'm sorry, but like, have you seen somebody with a shirt with that on? Like, all the hipsters like to wear that shirt. So we can make a program to generate that shirt, that album cover. It's an album cover by a band called Joy Division. Python 3 joydivision.py. And so I've made that program, and of course the turtle is not going to show me it itself. There it goes. So there it is. It's running and it's building it. All right. It just so happens that that album cover comes from the readings of a celestial object called a pulsar. So it's out in the universe. They some grad student shoved a satellite, pointed it at this pulsar with this name, and got some readings of it because it pulses every few seconds or something. And they got the reading of the pulses, and he made a cool graph in his dissertation or something that looked like this. All right, so that's what happened. And you can, taking those readings, like there's just energy levels, like the signal. I made a list of lists. You can get the data, like, all right, here's the signal's strength, and then it got a little less strong, got even less strong, got a little more strong because it went from here to here. So like, you can just graph this, like, all right, go down, go up now, go up some more because you got less negative, go down. So like, you can take all these and like make a graphing program, like in the turtle library. Just tell the turtle, go, all right, go down a little bit, go up a little bit, go down a little bit, sorry, go up some more, stuff like that. And like, take all the rows from the reading back in the 70s. And that's all you need. Just like, I've made a bunch of functions and it's using the turtle library. Like, all right, draw a rectangle, draw a line, draw a fuzzy line like this. And so it gets a little complicated, but like, here's for loops in Python. It's just all working. And so yeah, just like, I'm looping through that signal and like telling it to draw a little fuzzy line based on the readings if it goes up or down. And so you get the Joy Division t-shirt or album cover printed back to your screen, which is beautiful. And then an even cooler fact, it looks better because you have a turtle at the bottom right too. So just a fun little example. I could not hope to explain it all to you, but it's a fun little example that you can read and look at and ask me questions about if you'd like. But yeah, that's my last cool example of the day, I think. And yeah, that's languages other than C++. I hope that you enjoyed that and you saw that it wasn't horrible. Do take advantage of like all the online tutorials. Like there's plenty of stuff. It's not that hard. Even if you're forced to have learned it already, by the time you get to a 4-year college, it's going to be okay. All right, you are capable of learning this stuff. So yeah, that's my pep talk for the day, and I think that's all that I've got. So I will see you next time.